Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAFIYUDDIN bin Abdul Muttalib. Today, I would like to present my final year project that is special helmet for people with hearing impairment, supervised by Dr. Yu bin SEOK. First of all praises and thanks be to Allah for giving me good health and also my supervisor who will be guiding me going through this project. In Malaysia, people with disabilities are allowed to drive or ride motorcycles on the road. However, for those with hearing problems, there will be problems when the emergency vehicle approaches from behind. Generally, normal people will be alert to the siren sound. For those who having critical hearing problem, will not notice unless they see through side mirrors. The emergency vehicle approaching at fast pace can cause accident to the rider, and more dangerously, it can also harm the victim inside the ambulance that are rushing for treatment, and also fire brigade to the scene to put out the fire. A blue light signal has traditionally been used over the year to flash warning because deaf riders might not detect the siren. But still, it's such a problem on broad daylight or heavy traffic that may block the light. Objective of this study were to design a helmet with the alternative alerting system, considering the functionality, the design itself, and also can fit all the required components for the system to work. Next is to develop the alerting system with the most suitable sensor to detect the emergency vehicle and the most efficient output. Lastly, to test the effectiveness of the system, either it can detect siren or honking from a distance. This project helped deaf riders alert on the siren and honking. It keeps them safe on the road. It also helped to provide clear passage for the emergency vehicles that are in rush to complete their emergency missions. As far from the reviewed previous research, there is no yet proper device for people with hearing impairment to communicate with emergency sirens, especially for the motorcyclists. Even though records of motor vehicle accidents from the Rochester Institute of Technology show that deaf and hard of hearing drivers are nearly 3 times more likely as normal persons to be involved in a motor vehicle accident. Thus, providing special assistive embedded device for them is a huge impact to reduce the risk of road accident. Now, I will show you the 3D model. The LED will be placed inside the helmet, which the visor can reflect the light. You can see at the back part the placement of the sound sensors, and at the bottom there is rechargeable module with the micro USB interface. Now let's see all the placement for the electrical components. You can see that all the electrical components are nicely fit to the helmet design. Static stress analysis was performed on the helmet by using Fusion 360 software simulation. The model of helmet is prepared in Fusion 360 software, and it is based on the shell alone. Analysis is performed with 3 different materials. The first one is carbon fibers. The next one is ABS plastic, and lastly polycarbonate. The design product will be tested with 3,432 Newton load, which is when the conventional fiberglass helmet having major deformation when the force applied to it vertically. This is to replicate the hydraulic press. From the result, we can conclude that carbon fiber is the most suitable material since it experiences the lowest stress, resulting in the lowest strain. Moreover, carbon fiber having very slight displacement compared to the other two that almost completely deform. Lastly, carbon fiber also has the highest reaction force. How the system works is the sound must exceed the threshold value. Then the LED should flash light as the output. The sensitivity of the sound sensor can be adjusted using the potentiometer on the sensor itself. In Malaysia, the driver is recommended to be 2 or 4 seconds behind the front vehicles. This is considered the safest distance. In order to test the functionality of the system, an experiment was conducted to detect car horn and also motorcycle horn with 3 different levels of distance, starting from 4.7 meter, that is about length of a SUV car. The second one is 9.4 meter, that is double of the original distance. And lastly, 14.1 meter, that is 3 times further than the original distance. Typical car horns are approximately rated around 107 to 109 decibels. Meanwhile, motorcycle horn is rated around 96 to 105 decibels. For the joint, all the components are joined by using rigid joint, and only for the visor is using revolute. This is to replicate the usage of fastener, which to make the visor to be able to open and close freely. For the rigid joint, most of the component will only use snap fit and also adhesive. For manufacturability of this design, the first one is the carbon fiber shell. One method of producing CFRP parts is by layering sheets of carbon fiber cloth into a mold in the shape of the final product. The alignment and wave of the cloth fibers is chosen to optimize the strength and stiffness properties of the resulting material. The mold is then filled with epoxy and is heated or air cured. The second one is the visor, also known as PC. Polycarbonate is an adaptable thermoplastic that's durable and pliable, able to be injection molded and thermoformed. Lastly is the inner padding. Granule of EPS, known as bead, are placed in mold and expanded with steam. Questionnaire had been conducted using online platform with total of 134 respondents, mostly among parents of deaf children. 97.8% agreed that special helmet with an alerting system can help deaf riders to notice incoming emergency vehicles. They are also willing to pay extra money for the helmet. This is model canvas for the special helmet. For value propositions, the helmet provides additional safety features, cope with the lack of alertness of sound with the visual response, and it comes with modern design. For the customer segment, it targets to the deaf people, elderly with hearing problems, and people with hearing aid.